Hi, I'm Dr. Jackie White from St. Leo University, and Tally here has come to visit today to get some help with talking about types of data. So what we're going to begin with are a few different definitions that we'll need as we go through this section. First, we have that a parameter is a numerical measurement describing some characteristic of a population. So the key there is that parameter goes with population. Then we have that a statistic is a numerical measurement describing some characteristic of a sample. So statistic would therefore go with sample.
It sounds like parameter and statistic are the same. Can you give an example of what the difference is?
Sure. If we took a look at the Congress of the U.S., we could look at the fact that there are 87 men and 13 women. So when we're talking about the Congress, we're talking about the entire group. So that would be a parameter. Now, on the other hand, you've probably been waiting in line for textbooks. So if we looked at the average amount of time for waiting in line for a textbook, let's say your statistics textbook, and that was 0.65 hours, we'd probably only look at a sample of students to get that average of 0.65 hours rather than all students. So that would be a sample.
That helps a little. The word sample in the example helps to identify the second one as a sample. Going back to the definitions, does it matter what the type of data is, or how we would even know what the type of data is?
Well, yes, it does matter. There's quite a few different types of data, and so why don't we talk about that for a little while. We've got quantitative data, which is primarily numerical data, so it consists of numbers that are representing counts or measurements. On the other hand, we also have qualitative, which can be called categorical or attribute data, and that can be separated into different categories that are distinguished by some non-numerical characteristic. Beyond that, we can continue to break down our data. We have discrete data, and so if we talk about discrete data, that will result when the number of possible values is either a finite number or a countable number, and that word countable there is kind of a key word. For instance, you'll have numbers like 1, 2, 3, 0 if there are none. You'll have different numbers that result when you're counting. On the other hand, if you look at continuous numerical data, that will result from infinitely many possible values that correspond to some continuous scale, and that covers a range of values without gaps, interruptions, or jumps.
If several sets of data were continuous, would they all be considered the same?
Well, let's go ahead and look at an example first of continuous and discrete and talk about that a little bit. We could look at the idea of chicken eggs. If you went into a hen house and you were going to look at the chicken eggs, you would count them. You'd say how many chicken eggs were laid. And so because you're counting them, you'd have a number such as 1, 2, 3, however many there were. And so in that case, that's an example of discrete data. On the other hand, if you went into the barn instead, milking cows, I'm sure you do that regularly, but if you're going to do that, you're going to measure how much milk you've gotten. And so it could be between, say, 0 and 5 gallons. And so it might be something like 2.663 gallons or something like that. That's a continuous number. And actually, you might milk it, and wow, this cow gave me 2 gallons, and it seems like it's exact and a whole number. But technically, if you got a more accurate measuring instrument, it might be something like 2.01 gallons or something else. And so it could take on any value within a continuous range. So it is a whole number, but that doesn't necessarily mean discrete. We counted it for chicken eggs, that was discrete. But when we looked at cow's milk, we measured it. And so that would be continuous data. But as far as then breaking down the different data, as you were asking about, we have different things called levels of measurements. And there's 4 different levels of measurements that we can look at. We would start with the most basic level, which is called the nominal level of measurement. And that's characterized by data that consists of names, labels, or categories only. And this cannot be arranged in any kind of ordering format. And so in this case, then you've just got categories. We've got a second type of data that we can look at, or a second type of measurement, and that would be the case that the ordinal level of measurement. If they can be arranged in some order, but the differences between the data values either cannot be determined or are meaningless, then we'd have a case of the ordinal level. Let's take a look at the interval level. And when we're done looking at each of these levels, I'm going to go through an example. And in that example, we can kind of go through the levels again to make them a little more clear. So what we have is the interval level of measurement. And so that's like the ordinal level with the additional property that the difference between any 2 data values is meaningful. However, the data at this level do not have a natural 0, which was kind of a hint for the next level because that's what is not satisfied by this level. And so if we go on to the last level of measurement, then what we would have is the ratio level of measurement. So taking a look at the ratio level of measurement, it's the interval level with the additional property that there is also the natural 0. And so in this case, you've got a natural 0 starting point, where 0 indicates that none of the quantity is present. For values at this level, differences and ratios are both meaningful. So we could go back to these levels and look at an example going through the 4 levels. How would we classify data in one of these levels? So let's go back to the first level, the nominal level, and let's look at NBA. I'm sorry, we're women. Let's look at WNBA heights in this case. Doesn't really matter. In either case, you're looking at heights. So your data would take on values like 5'11", 6 foot, 6'2", different heights of the women in the WNBA. The way you would take any particular data set and try to determine what level of measurement it fits is to start at the nominal level. Any data would satisfy the requirements for the nominal level. So we'd look at that, and is the data you'd look characterized by data that consists of names, labels, categories? Well, sure, they're heights. So we know that nominal is satisfied. So what we would do next is say if nominal satisfied, which they all are, you can actually skip that step and go right on to the next one, which is the ordinal level that we looked at. And say, is the ordinal level satisfied? And that means, can you arrange the data in some meaningful order? Now, you can always put things in alphabetical order, but does the order have meaning? Well, in heights, sure, you can go from the shortest to tallest or tallest to shortest. So the order is a meaningful order. That means the ordinal level of measurement is satisfied. So now we ignore the nominal because that's the lowest level. Whatever the highest level is that's satisfied, that would be a result. So far we've worked our way up with ordinal. So we know this data satisfies ordinal. But we still need to look at the next level. And so in the next level, we're going to look at interval level of measurement. And do our heights satisfy this? In this case, you have to be able to tell precise differences between your data points. For instance, if the data points were 5'11" and 6 foot, can you tell the difference between those data points? How much difference there is between 5'11" and 6 foot? It's 1 inch. And that's that's a precise difference that has meaning and will always be 1 inch if you have 5'11" and 6 foot. So now the interval level is satisfied. So ignore the prior level and look at now interval level. And that's the level. If we move on finally to the ratio level, that's the highest level of measurement in our scale as we're going up. Does our data satisfy the ratio level? And that's where, remember, we had that 0 starting point, absolute 0 or natural 0. And that would mean, does 0 have meaning in terms of height? Sure, 0 means there is no height. There's none of the height. And so that does have meaning. Or you can look at it in terms of a ratio. For instance, if you took two heights, 3 feet and 6 feet, is 6 feet twice as high as 3 feet? And yes, so the ratio is precise and meaningful. When you double the number, you double the height. And so in that sense, the ratio level of measurement is the one that's satisfied. So those would be our 4 levels of measurements. And in this case, we satisfied the ratio level. And that whatever the highest point is, that's where you stop. That's the level that's satisfied. Ready for an example? Yeah. Okay, let's take a few minutes here. We'll look at an example from Consumer Reports. The Consumer Reports magazine gives the ratings of Best Buy, recommended, and not recommended. So that means the data that you'll receive are results of either Best Buy, recommended, or not recommended. You'll have those 3 different results intermixed with, that's what your data set will be made up of. So what I want you to do, and I also want everyone who's watching us to do this as well, is to try and determine what level of measurement is satisfied in this case. So we're going to pause the video here, give you some time to work on this problem. When you finish, we'll get started again and go over the answer. Well, Tally, you've been working on this answer. What did you come up with?
Well, when I test this one with the ordinal level of measurement, I see that I can put them in order from best to not recommended, so it satisfies the ordinal level. However, I cannot determine a meaningful difference between all classifications of Best Buy and not recommended, so I would say that the ratio level is not satisfied. So I guess my answer would be ordinal.
There you go. It looks like she's got the hang of it. So we've got ordinal as our level of measurement for this particular example. And that concludes our discussion of types of data. So I hope it's been helpful for you, and I look forward to working on some additional different concepts in the future.